Okay, so in this activity that you guys went through, we were kind of getting an introduction into sequences and series. So I just want to go through and talk about each of these activities that you went through. So the first one was observing this pattern. So you can see we have the triangles over here. We have three kind of stacked together. Then it kind of flips, sits on top of itself, then it flips again. So the pattern is actually increasing three triangles each time. You don't really need to talk about how they're getting placed unless you want to. They're just flipping over each time. They're kind of a reflection, but just knowing the fact that there are three more triangles each additional time. Okay. Then it says, well, how many would there be in the fifth term? Right. So I have three in the first group. I have six in the second. I have 9 in the third. I'm going to have 12 in the fourth, which means I'll have 15 in the fifth term. Okay. And then how many triangles would there be in the sum? So that's just adding them all together. So you can see if I was to add 3 plus 6 plus 9 plus 12 plus 15, I'll get 45 total triangles with the sum of the first 5 groupings. Okay, then we get into these actually, before we do that, how many would be in the nth term? Well, if we go back and we look at this pattern, it goes 3, 6, 9, 12, 15. They're all increasing by 3 each time. So it is just going to be 3 times n, right? 3 times the first position, there was 3 triangles. 3 times the fifth position, there was 15 triangles there. Okay, here's our bars. So now, again, looking at it, describing the patterns. There's a couple different patterns that we can look at here, in fact. So we can look at the 2 bars separate. So we can have, a 2 height bar and a 1 height bar in that first grouping. We can have a 6 height and then a 3, okay, and so forth and so on. We could add them all together. I have 3 total in height with the first grouping, right? A 2 and a 1 is a 3. I would have 9 in the second. The 6 and the 3 gets us 9. All right. So again, it's however you want to look at it. But bar 1 is double the amount of bar 2. That's one way. Or each grouping ends up being 3 times more than the one before. I went from 3 to 9. I'm going to have 27 in the next one. Okay. Same thing as before. We want to figure out, well, how many are in the fifth pattern and what's the sum? So again, we want squares total. So they're adding up all of those pieces. So 2 plus 1 is 3, 6 plus 3 is 9. We have 18 plus 9 is 27. And we're increasing by 3 times the amount each time we do this. So that's where the 54 and 27 comes from. And then the 162 and 81 gets us the fifth to be 243 total. And again, we would add up all the total number of squares to get 363. Okay, now in this case, trying to find the pattern, which is going to be the next part, I'm going to refer back to this chart here. I go 3, 9, 27, 81, 243. Again, those are all multiples of 3. 3 to the first power is 3. 3 squared is 9. 3 cubed is 27. We know all this, right? And I'm multiplying each previous one by 3, so the exponents are increasing. So in fact, our rule will be 3 to the nth power, right? 3 to the fifth power is where the 243 comes from. Okay, we get a little bit of notes. Sequences is that sum. So, sequences is the pattern. Series is the sum. So there is a special formula for the sum. It uses this big E. We call that a sigma or summation notation. And we're going to be learning about both sequences and series in this upcoming chapter. So the next few questions, still, this was just dragging. It's a linear formula, 3n minus 2. You're just plugging in 1 at a time. And you get this, right? 3 times 1 minus 2 is 1. 3 times 2 minus 2, that's 6 minus 2 is 4, so forth and so on. You do the same thing, plot the sequences here. So you're just dragging the pictures The equation for that would be 2n minus 1, right? Each of these are increasing by 2. And then to find your b value, think of it like a linear equation. It's a negative 1. All right, we have some fractions. Again, just dragging them over. And in this case, well, how do I get the rule of n plus 1 over n? Well, if I look at it, I have 2 over 1, 3 over 2, 4 over 3, 5 over 4. Each of my numerators is increasing by 1. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. So that's my n plus 1. I'm increasing each time. And 1, 2, 3, 4 on the bottom, that could be my n value. It's still increasing by 1, but it's also 1 less than my numerator. So if I have 1 on the bottom, well, 1 plus 1 is 2. That's going to be my numerator. If I have 2 on the bottom, 2 plus 1 is 3. That's my numerator. If I was to go to, say, 7 is my denominator, well, 8 will be my numerator. It's 1 more than the bottom number. Okay, and that is kind of what I'm talking about in this next situation here. All right, the last couple questions talk about summation. So it's just adding them all together. So they're telling you, you take the little formula here, 2k, and you're going from 1 to 5. So all you're doing is filling in all the numbers. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. And you figure all that out in a calculator, you get 30. If the equation gets bigger, you still do it the same way. We're going to go from 3 to 6 this time. So you're going to have 1 plus 3 squared. Find out what that is. Then do 1 plus 4 squared, 1 plus 5 squared, and 1 plus 6 squared. Add up all those values, you do get 90. Okay. And again, this is what we're going to be going through in this upcoming chapter. So hopefully it kind of piqued your interest a little bit. It's all about patterns and finding sequences and the summation of the total amount of values we're looking at.